Thank you for having me, and thank for everyone that's on the other side of the screen. I know that it's a bit light over there, so thank you for taking the time to watch my composable new world, this composable new talk. I know that since this is the end of the day, I bet you're all tired. So just to guarantee that no one falls asleep, let's just stretch a bit, okay? Let's put our hands forward and up. Okay, so let's start. So my name is Carlos Mota. I'm from Portugal. You can find me on Twitter at Mota. I'm an Android GDE. I'm the founder of GDG Coimbra that's in Portugal and the co-founder of Kotlin Nights. I've been writing for Wonder League. I have this dream of one day having my own podcast. I've been saying this a lot. And I love to travel, photography, and running. And I truly hope that on the next year or the year after, we'll be able to be in person and can switch from these online events to in-person events. I've also been working for Android for the past 10 years, and for roughly the last two, I've been playing a lot with Kotlin multi-platform, business logic across different applications. I've created a couple of materials for this talk. I've shared the links here on the chat, but you can find them on my speaker deck. On my GitHub, I created a sample application that uses Compose, that's called Unsplash Compose. And I've also created a project that uses Compose and also shares the business logic, the network request, the database with all the platforms, and everything is done using Kotlin multi-platform. So before we start, let me start by a brief history of Android time. And the Android UI Toolkit team had an amazing work so far. Android was initially released 1.0 at the end of 2008. We've been seeing a lot of different versions and APIs since then. We had Android Studio, which was great. I'm not sure if anyone that's out there still used Eclipse, but Android Studio helped a lot on programming for Android. We also had the recycler view. It's a big mark. In the end of 2014, we finally could get rid of list views and use recycler views, which was more powerful. We had the constraint layouts in 2017, and it was also in 17 when Google said, okay, we now accept Kotlin to develop for Android. And now finally, with Kotlin, or along with Kotlin, we've got the Jetpack Compose 1.0 that was released a couple weeks ago. And a few days after this initial release, we've got Jetpack Compose 1.0.1 that has support for Kotlin 1.5.21. So you can use, I'm not going to say the latest one because it was released 3-4 days ago, 1.5.30, but you can use it with one of the latest versions of Kotlin. So I'm guessing everyone is excited. I cannot see your faces, but I'm assuming you are. So let's start. So perhaps the first question is, what's Jetpack Compose? Okay, I went to Google and asked, okay, what's Compose? And basically it says, according to the Oxford Language Dictionary, write or create a work of art, special music, or poetry. And I thought, okay, this is perfect. This is a really good name. And I bet Google in the upcoming years will change this, write or create beautiful piece of Android code. Of course, if we go to the Compose website, we can see another type of words, another type of buzzwords like less code, it's intuitive, it makes you develop your application faster, it's powerful, all of those big words that I can also add that it allows you to have smaller APKs, it's intuitive, it's unbundled from the OS, meaning that, for instance, on Android 11, if I'm not mistaken, it was launched a new feature where you can animate a keyboard. You can access its visibility state, you can know its height, etc. But this is only available on Android 11 and Android 12 and afterwards. Now with Compose, since this is not bundled to the OS, You can use this feature on Android starting Android 21, API 21. And you cannot use it on lower versions because Compose only works on API 21 and afterwards. It's open source, it's a modern framework, you write a lot of less code, which means that you're going to write a lot less bugs. And an important word here is that you're going to use declarative UI. So it's going to be a shift, a paradigm shift on how you program your UI that transitions from imperative UI, that's what we're doing now with XMLs and click listeners and adapters, to declarative UI, which is entirely different. Let's see an example. Imagine, and I'm assuming that 90% of the apps use this, imagine that you're going to show a list, a really simple list, and we're going to implement it doing imperative UI, meaning how we're implementing lists nowadays. So you first create an activity, then you create the corresponding XML, then typically you would create a fragment, then the fragment's XML, then you create the corresponding recycle view, where you're going to have your list, the adapter, and then at least one XML for the items. And if you're going to have different type of items, let's imagine an header and a custom row, you're going to implement more and more XMLs. So to do something simple that almost every app has, you need to at least create 5 files and to write at least 200 lines of code. And I'm being optimistic on these 200 lines of code. If you count the XML, the adapters code, everything that you need to override, you probably will end up with 500 lines of code easily. So this means that to implement something easy, you're going to be time consuming. Since you're going to write a lot of code, it's error prone, so you might end up creating bugs. You end up creating several files, which also will increase the API size. Since you're going to write more code, your build time will increase, and you're going to have coupled components. Now let's see another example with imperative UI, or I like to call it, let's see a brief history how to change the access and change the state of a view. Let's see a simple example. We've got a view called Hello World, and basically in the beginning, if you want to change the text of Hello World, or if you want to set Hello World, you would do something like this. You needed to call find view by ID, send the ID reference from your XML file, and then you needed to cast to text view. If you didn't cast to text view, the program wouldn't compile, and if you cast it, for instance, for image view, your application would crash. Then we had Jake Wharton launching Butterknife, and basically you could just use the annotation bind view, and you could use directly the field that you created. So you could easily access on your code greetings.txt and set hello world. This implementation was great. If I'm not mistaken, it used reflections, so it wasn't the fastest one, but it worked great, and a lot of people used it even today. Then Google optimized the process, and you no longer need to cast because it knows what it is when you call find view by ID, it understands its type. And then come along, we have Kotlin with the synthetics, where you just needed to import your layout, and you could easily access your views, your components by using the ID. Then Kotlin decided to deprecate this, and now we have view binding. View binding, you just need to enable it on the Gradle file, and you can easily access your content by just creating a binding, basically calling fragment main binding.inflate, and this fragment main binding is generated compile time using your layout name, and you can easily access each one of the components by just accessing the ID without the underscore. So everything is done for you, just need to call the inflate and then access the binding object that needs to be global. If we now look at, let's call the main component of every view, it's view.java of every component. And if you look at text view, it extends view.java. If you look at image view, it extends view.java. If you look at view group, you guessed it, it extends view.java. If we want to look at linear layout, it extends view group that extends view.java. If you look at relative layout, it extends view group that extends view.java. Okay. Almost all components extend view.java on one way or another. And this class, if you go to the source code, has hundreds of lines of code. it's it might be crazy. Imagine that you're the developer that needs to change a single line of this file. Imagine what will happen if you break something. You might break all the components. I know there are Unity and instruction text that will solve this, but the pressure of changing anything on this class, it's awful. So this file, the view.java, it's really difficult to scale. It's hard to maintain, almost impossible. Every change might end up changing or have an impact of a lot of classes, and you're bundled to the OS and the OM's implementation of these comments. And if you're developing for Android and you need to develop and you test your application on different devices, I bet one time or another you've noticed that you're running your application on a specific device and then you're running on another device and you have a different behavior. This means that typically the manufacturer, the OM, decided to change because some reason that component, and your application changed its behavior based on that component. A really simple thing happened a while ago. For instance, if you're using a Samsung phone and you're scrolling through a list, you typically would see a gradient, a different color when you reach the top or at the end of the list. But that only happened on Samsung devices. This was an implementation that they did on their side and created different behaviors on the same application running on different devices. So the goals behind Compose is to unbundle from platform releases, so you can use new things on older versions, and to be faster to implement new designs, views, and components. And this is entirely true. After a while, after you get familiar with Compose, you'll see how easy it is to reuse the same components to add specific features. It's way simpler than using XML files. Also, you have a more clear understanding on who's the owner of that view, of that state, and how to handle events. So if you put side by side imperative and declarative UI, on imperative UI, you have to written your code in Java or Kotlin, and you need to write your XML for layouts, attributes, styles, themes, dimensions, everything. In declarative UI, its UI is a function, you've written it in Kotlin, and it's your only Kotlin code, which is great because you can take advantage of the full Kotlin set of features. Oh, a simple way to see the difference is, for instance, imperative UI, it's how things should happen, and declarative UI, it's what should happen. And there is a really good blog post about this made by Google on the Android Developers Medium. That is, how do you implement this? An icon that changes its behavior depending on the number of unread messages or unread emails. If you have less than 100 emails, you're going to show a badge and an envelope and a paper. And if you have 99 message or more, you're going to show a fire and an envelope. And you're going to just say that you've got a lot of message and you don't care about the number. So how do we implement this doing imperative UI? It would be something like this. So as you can see, it's a lot of code to create a simple mechanism. And this might not be entirely correct. This is a bit of pseudo code, okay? Please don't tell me, okay, you forgot to send a perimeter or something like that. No, this is just an example. And typically, when there is an update, you received a new message and you didn't read it, you're going to call update count with a new count. So if the count is bigger than 0 and you don't have the badge, you need to add a badge. If the count is 0 and you have the badge, you remove the badge. If the count is more than 99 and you don't have fire, you need to add fire and set the badge as 99 plus. If the count is less or equals than 99 and you have fire, you remove the fire. If the count is 0 and you don't have a paper, you add a paper. If the count is 0 and it has a paper, remove the paper. If the count is less than 99, you set the badge text as the number that you just received. Okay, so we've got a lot of if else just to create a simple example. If we now move to declarative UI, okay, you can implement the same thing doing something similar to this. So you've got a composable function, and we will see in more detail what means to have the composable on top. Basically, you need to use if you're going to change the UI, and then you have your function to draw the envelope, and you just say the parameters there. This method will be called every time the value of count changes. So you can implement the same thing with 5 lines of code. 4. So I think we have a clear winner here. Declarative UI. I've even added an animation here to make it cooler. And now that you've seen the advantage of this new paradigm shift, it's time to explain a bit more what Compose is. Because Compose, there is more to Compose than Compose itself. For instance, this was a message that Jack Wharton published on Twitter a while ago. Basically, he was saying that, okay, I've created a Compose for iOS. It's not Compose UI, and you'll see what's the difference. But he was able to run Compose on iOS using UIKit. Of course, Jess Wilson joked a bit with this, saying that, okay, we now have Compose for Android, browser, command line. This is a project that I think it was Wharton also that created, called Mosaic, iOS, and one day the garage door opened. That is a project that Wharton already has. And I can also add to the list that we also now have Compose for the web thanks to Jetpack, to JetBrains. So if we go through Compose, there are a lot of libraries, okay? And I think it makes sense to split them on almost half. So on the bottom, you've got the Compose compiler and the Compose runtime. And then on top of these two, you have everything that is focused on the Compose UI toolkit for Android. Although the Android team and Google calls Jetpack Compose to the whole set of libraries, what Wharton says, and I agree with him, it makes sense to split between both because Compose compiler and the runtime are really powerful tools. The compiler allows to transform composable functions and to enable optimizations. It's totally written in Kotlin. It's open source. It's available on the IOSP. It doesn't use an annotation processor, so it's really fast. It works at the system code generation level, and it has minimum or none impact at build times. The runtime, it's platform agnostic, so it doesn't know what's above it. It doesn't need to know what Android or what UI is. You can use Compose without UI, and it's a tree management solution. So basically, you just need to feed them what you need, the mappings, and it will be able to handle everything. From here, also a really good code that means that Compose is at its core a general purpose tool for managing a tree of nodes of any type. A tree of nodes describes just about anything. As a result, Compose can target just about anything. And this is why you're seeing now Compose for desktop and Compose for the web. JetBrains was able to port the Compose UI toolkit to the desktop and to the web. But we have 4 more libraries on our diagram. So it's Compose UI, Foundation, Material, and Animation. What this means is the animations, well, as the name states, it's responsible to create easily animations, fade in, fade out, etc. The material, it's responsible for the material design. You can easily use material design components that are themes that are already created on your application. The foundations allow you to use text, image, row, columns. It's the composable function that you're going to use to write text, an image, or to stack. It's similar, row and column are similar to view groups. And the UI that handles the input management, drawing, layouts, etc. So we can split them on both, and we have Compose runtime and compiler, and now we start to have Compose UI for Android, desktop. You can even have Raspberry Pi here. the web and the console through Jack Wharton's Mosaic project. So it's important to once again mention that you now have Compose multi-platform in alpha for desktop and the web. Android is already stable, and you can. I'm not going to say easily because sharing this is there are some tricks to implement this, but I'm going to say after 1 or 2 nights of sharing your of implementing your project, you're able to share your Android code across the desktop and the web. I've got, I think I have on my GitHub a project with this where I'm sharing the UI. There are, of course, there are a couple of things that I need to implement on on the desktop side because it's different. For instance, you need to implement a scroll bar. For instance, um, on Android, I'm using Coil as as an image library. This doesn't exist for desktop, so I needed to use another functions and so on. For simple things, it's easy. If you want to create more complex things, there's a big more work that you need to do. So the big question here is, should I switch to Compose? Well, there are already a couple of applications in production. I believe that you recognize at least some of these applications, if not all. This doesn't mean that they are 100% in Compose. What this means is that these applications already have parts of the applications in Compose. So developers from Twitter implemented a new feature, they went for Compose. And there are a lot of comments from them saying that it's incredible and they want to just keep exploring Compose and making new views with Compose. Another good example is this application. This was developed by Chris Bain. It's called TV, and it shows all the movies and series that are on the TV. And he made this a couple of years ago, and last year it's decided to start porting it to Compose. So we basically need to refactor all the UI, and after refactoring to Compose, you notice that the APK size reduced 46%. So his application was initial 4.49 megabytes. It's now 2.32. With this, was also thanks to the method count that was reduced in 70%, and the lines of source code also reduced a lot. Since you have less code, it also means that the build speed decreased for 29%, meaning that he was able to create builds faster than before. Of course, that it's also worth to mention that during this period, Gradle also improved. There were newer versions, but in the end, you can see that writing in Compose has a lot of advantage even for your final application. So, should I switch to Compose? Yes. Although Compose it's in its beginnings, it's on 0.0.1, there are a lot of libraries that already make our lives easier. For instance, the Companist library is a set of libraries that was initially created by Chris Baines, if I'm not mistaken, and now are under Google's umbrella. And they allow you to develop easier, to faster, and make your life easier. For instance, if you want to implement the swipe to refresh, where you push a list, for instance, you can develop this in something like 6 lines of code. If you want to request permissions, you can easily do that. A pager, it's like 3 or 4 lines of code. So I'm saying that if you want to start developing for Compose, go for it, because after you get that initial learning curve, it will be way faster for you to implement your applications, your designs. I've mentioned previously that there were some features that are now available on API 21, for instance, such the keyboard DMA animations. These are possible because we're using Compose and we have this insets library that allows to implement everything. And to be honest, I've implemented this using XML files, and it took me a lot of time to have everything perfect, pixel perfect. And with Compose, I remember that a simple animation that was the user was scrolling through the list. It was a short application. The user was just scrolling through the list, and I wanted the keyboard to open. With Compose was 1 line of code. Okay, and I've written hundreds on XML. You also have another library that's Coil. It's fully Kotlin. It works really, really well with Compose. You've got Lottie for animations, and you start to have, I'm going to say, every month or every week, new libraries that are being launched to make your lives easier. So I'm guessing that you all know how to start. So grab your laptops, open Android Studio. You need to use Arctic Fox for this, or Bumblebee, for instance. Just go for empty compose activity. You create your project, and then you're going to see this Gradle configuration file. So the minimum SDK is 21. It's going to use the IR compiler. You need to set compose as true, although I believe this is now enabled by default, if I'm not mistaken. And if you create an empty activity, you're still going to have 1.0.0, but you can also update it to 1.0.1 that uses the Kotlin compiler 1.5.21. You need to add these libraries. The tooling preview is just for you to see the rendered image on the right. You need to use Activity Compose, the UI that already gives you a lot of materials. But let's see a simple example on how, for instance, to add text. So without Compose, you do something like this. You created your text view, you give it an ID, you're going to say that I want it to be wrap content and have the text hello world. Okay. And now if you want to change the text to hello Android, you're going to do something like this. You're going to find view by ID, access text field and say, okay, it's hello Android. With Compose, you just do this. Yeah, text, you say the text that you want to show, and that's it. Easy, it's a function. If you want to change that name, for instance, you can just create a composable function, for instance, greeting. This is the one when you create your sample project, you're going to see this function, and it receives a name, and it will just print the name that you're going to enter. So as you can see here, this function has the composable on top. You need to use this annotation if you're going to draw on your UI. You always need to have a function implemented. And then you need to call other functions, in this case text, but it could be image, could be a row, could be a column, could be an icon, a button, etc. And then you just send the parameters that you want to send. In this case, I just set the text as a string. If I wanted to access, for instance, a string resource, I would do something like call a string resource, it's r.strings.value. I would call string resource instead of calling get string and just send the string ID. Now let's see the concept of view groups. Without Compose, we do something like this. We'd use a linear layout with two text views, for instance, to stack one on top of the other. If we'd use Compose, we do something like, let's add another text. Oops. Basically, Compose, it will always draw on the same place, unless you're going to use a particular function called column that will, well, create a column and you will be able to stack things one after the other. Of course, along with column, you also have the row. Let's say that you change the orientation and you're going to have them horizontally. It follows the row, the direction. So let's imagine now that we want to change the color. We use for this the modifier that has a lot of attributes that you can set. In this case, I want to change the background of the text to green. So I'm going to just call the modifier.background and set its green. Now imagine that I want to make all this view green. I'm going to call fill max size. I'm going to say that this column will occupy the entire screen and I want this screen to be green. Now let's imagine that I want my view to be just with a small padding. If you look closely, it will going to move. It's a 16 dps, so you need to call the dp function. So it's no longer a string and it will move 16 dps left, start, end, top and bottom. Now let's imagine that I want to center this on the screen. I've got an horizontal alignment that I'm going to say that I want it to center horizontally, and I'm going to call vertical arrangement saying that I want the arrangement to be centered. Now I have text, and I think that I want to customize this text, and I think the perfect color here it's going to be white. I bet you all can see it really, really well. So I'm going to call the function color, or I'm going to send the attribute color, and I'm going to say that it's white, and it will automatically change the color to white. Now let's go to images. So without compose, you would use image views. Okay. Now that we want to use compose, we're going to use an image function. So there are a bit of differences here. So an image needs to receive a painter resource, meaning that it's the ID that you want to draw over there. So I want to use the launcher icon to be displayed. And it's also mandatory that you set the content description. If you didn't define the content description on the XML files, you would see a warning saying, okay, you need to do that for accessibility. On Compose, it's mandatory that you define the content description. Without Compose, if you want to add a button, we do something like call button and just set the text as plus just to increment it. It seems I still didn't have my own coffee, so it's 0. If you want to do it with Compose, you call the Compose function, you set the on click, and then you add another text. In this case, I added the plus sign once again. Now let's change the state. I want every time that I click on the plus button, I want to increment the 0 number of coffees equals to 1, 2, 3, 4, 5, 6. If I would do this without Compose, I would do something like this. I have my global variable, it's initialized as 0. I'm going to get my string, and I'm going to send the number of coffees that I've already drank. Every time I click on the button, I'm going to update this count, and here basically I need to also set the TV message to this new value. With Compose, it's way simpler. Basically, you need to create a count, and you're going to use the function remember with the initial state of 0. This means that the value of this field will be kept in memory. So every time you click on the plus icon and you call on click, it will always increment in 1, 2, 3, 4, 5, 6, 7, 8. If you don't set it as remember, this value will automatically be always 0. Also, since it's a mutable state, you need to access its value in order to increment it. And every time this value changes, this entire function will be called. So this is the declarative UI. This case, this value was changed, so the system will automatically recompose it all of these functions. So the runtime will be minimum because it knows exactly what it needs to update, and you know who's updating that view. Let's see a quick demo. I've created an application for this. You can find it on my GitHub. It's really, really simple. And for you need to install Arctic for this. If you have a Mac M1, there is a specific version for Mac M1. Please install it because it's way faster than the others. And you just need to go to my GitHub, semota /and compose and download the project. I'm just going to make a quick overview here. This is the application that I've developed. I'm using Unsplash API to get the latest images. It's a two-screen application, meaning that I have a home and an about screen, and I'm able to navigate between one screen to the other with a navigation component, with a bottom navigation bar. If you see close, I've got here a gradient, I'm entering text, I'm overlapping text with images, I have a placeholder. So basically all the components that you typically need are on this project, so feel free to have a look. And if you have any questions, please don't hesitate to send me a message. Talking about resources, there are a lot of awesome resources that you can use to learn more about Compose. The Jetpack Compose samples are on GitHub, on Android Compose samples. There are 6 applications, if I'm not mistaken. They are all good examples that are always updated until the last version. There is also a great list of projects that you can search on github.com/jetpackcompose. There is the Compose catalog. There is the fuzz.github.io that has a lot of examples about Compose, and there is the amazing community that's been pushing Compose forward. I recommend you to watch the Twitch from Intelligible. It's from Leland. It's one of the developers from Google behind Compose. Go check it out. You also have the Joe Birch blog and Josh Castillo that I think he recently even launched a book about Compose. So feel free to see these resources. So I hope you've enjoyed this talk, and I'm going to pass the microphone back to you.